Sample test question number 10, partial fraction decomposition. I would like to decompose this rational expression into three parts based on the three factors of the denominator: the x minus 1, the x plus 2, the x plus 4. These are all first order, so I put a single constant on the top. My method for solving is going to differ slightly from the books, but it starts out the same. Multiply both sides by the denominator. On the left, of course, that gets you 2x squared plus 33x plus 40. On the right-hand side, multiplying the denominator by the first term, notice that the x minus 1's cancel, and I'm left with a times x plus 2 times x plus 4. When I multiply the b's, it's the x plus 2's which cancel, leaving me with b times x minus 1 times x plus 4. When I multiply the last term, it's the x plus 4's which cancel, leaving me with c times x minus 1 times x plus 2. Now the book would have you expand this expression and compare the x squared terms. You would have a plus b plus c of them on this side and just 2 of them on this side, along with the x terms and the constants. My approach is based on noticing that this should work for every value of x. So in particular, it should work when x is equal to 1. The advantage of letting x equal 1, that's a 0 of the denominator, is apparent when we see that plugging in 1 here makes this entire term 0, and it makes this entire term 0. When I plug in 1, I get 2 plus 33 plus 40, that is 75, is equal to a times 3 times 5. That would be 15a. If 15a is 75, then a is 5. I'll do the same for the other factors. So for example, letting x equal a negative 2. Here I would have 2 times 4, that's 8, minus 66 plus 40. That adds up to minus 18. Letting x be minus 2, notice that the a term cancels, the c term cancels. For the b term, I have minus 2 minus 1, that's a minus 3, times 2, this would be a minus 6b. Now if minus 6b is minus 18, then b is going to equal a positive 3. Finally, let x be negative 4. I separate these because what I write here is only true when x is equal to 1. What I write here is only true when x is negative 2, and when x is negative 4, I would have 2 times 16, that would be 32. Negative 4 times 33, that's negative 132, and plus 40. So this would be minus 100 plus 40, it's minus 60. On the right, plugging in a minus 4, the first term will be 0. The second term will be 0. The third term would be my c's. I would have minus 5 times minus 2, that ends up being 10c. Now if 10 times c is negative 60, then c is a negative 6. I haven't quite finished because I want to write this in the form of 3 partial fractions. So I need to rewrite it, plugging in my a, b, and c value, and the final answer will be 5 over x minus 1 plus 3 over x plus 2 minus 6 over x plus 4. The reason why we do partial fraction decomposition is because in calculus, towards the very end of Calculus 1 and the beginning of Calculus 2, we're going to be doing an operation known as integration. And integrating a rational expression such as this is difficult unless you turn it into partial fractions. This partial fraction would be relatively simple to evaluate as an integral.